At some point, nearly everyone asks the big question, does God exist? There are many ways to approach this question: philosophy, theology, personal experience. But in today's world, science is often seen as the gold standard for discovering truth. It's what we turn to when we want serious answers to life's biggest mysteries. So it's only natural to ask, can science help us answer the question of God's existence?
In this episode, we'll argue that the answer is yes. We'll explore 3 science-based arguments that together make a compelling case for the existence of God.
We're not claiming absolute proof. Outside of mathematics, that's rarely possible. Instead, we'll offer a science-based case grounded in real evidence, strong enough to persuade a reasonable person that God exists.
Some points we'll discuss include the history of the design argument, the fine-tuning argument from the constants of nature, the design argument from the laws of physics, the argument from the ordered initial conditions of the universe, why these arguments aren't God of the gaps, who fine-tuned the design God, and the multiverse. For all these points in more depth, watch or listen to the complete Season 1 of the Physics to God podcast on YouTube, Spotify, or Apple Podcasts.
Among the many arguments for God's existence, the design argument is one of the oldest and still one of the most compelling. At its core, the design argument points to certain highly ordered or complex features of the universe as evidence for an intelligent cause.
The basic intuition that design points to a designer has been shared by people across cultures and centuries, but it's also been developed into rigorous philosophical and scientific arguments by some of history's greatest minds.
The roots of the design argument go back to the ancient Greeks, and it was later refined in the Middle Ages by Jewish, Christian, and Islamic thinkers. Even the philosopher Immanuel Kant, who famously critiqued all classic arguments for God, believed the design argument deserved special respect and successfully points to an architect of the world.
In the modern era, the design argument was most famously articulated by William Paley in 1802 with his watchmaker analogy. He argued that just as a watch implies a watchmaker, the intricate design of living organisms implies an intelligent designer.
Paley's argument dominated for decades, until Darwin. With the publication of On the Origin of Species in 1859, Charles Darwin showed how complex life could evolve from simpler forms through natural selection. Biologist Richard Dawkins later called this idea the blind watchmaker, a way of explaining apparent design without a designer. Today, many people assume that Darwin's theory permanently buried the design argument. But that assumption is mistaken. The design argument is stronger today than ever before, not because of biology, but because of physics.
Modern physics reveals a level of precision and design in the laws of nature that makes the old biological argument seem modest by comparison. Even the atoms and molecules that biology depends on, the raw materials of life, are only possible because of a deep underlying design in physics itself. To borrow the metaphor, one of the most profound insights of modern science is that the blind watchmaker itself was intelligently designed to make watches.
To make this case, we'll examine 3 essential features of our universe and demonstrate how each points to an intelligent cause. The first argument focuses on the fine-tuning of nature's constants, the second on the structure of the laws themselves, and the third on the extraordinary order built into the universe's initial conditions.
Since each arises from a different domain of physics and could serve as an argument on its own, we'll begin by presenting them individually. Then we'll show how, when taken together, they form an even more powerful case.
Let's begin with the fine-tuning argument. 3 key ideas form its foundation. 1, fundamental physics. 2, the constants of nature. And 3, the quest for a theory of everything.
Fundamental physics is the search for the deepest principles that underlie everything in the universe. It's about uncovering the most basic building blocks of reality, things that can't be reduced to anything simpler. According to modern physics, the universe is built from fundamental particles like electrons and quarks. These particles aren't made of anything else. They're the bottom layer of physical reality. And they're governed by fundamental laws like quantum mechanics and general relativity, which describe how these particles move and interact.
The constants of nature are fixed numbers that appear in those laws and define how the universe behaves. The constants are not derived from any other theoretical ideas. Instead, they're precisely measured and inserted back into the laws. Physicists have identified about 25 of these constants. For example, the mass of the electron tells us how heavy it is. The fine structure constant, roughly 1 over 137.035999139, determines the strength of the electromagnetic force between electrons. These numbers don't change across time or space. They're woven into the fabric of physical reality.
A theory of everything is the ultimate goal of fundamental physics, to find a beautiful, unified, simple law that explains all the complexity and diversity in the universe, from the particles to the laws, and even the constants themselves.
Throughout the 20th century, modern physics made remarkable progress towards realizing the dream of a theory of everything. But one of the main obstacles that stubbornly remained was the specific values of the constants of nature.
Nobel Prize-winning physicist Richard Feynman laid out the problem in his 1985 book, QED. Listen to what he said about the fine structure constant. Quote, "It has been a mystery ever since it was discovered more than 50 years ago, and all good theoretical physicists put this number up on their wall and worry about it. Immediately, you'd like to know where this number for a coupling comes from. Nobody knows. It's one of the greatest damn mysteries of physics, a magic number that comes to us with no understanding by man. You might say the hand of God wrote that number, and we don't know how he pushed his pencil. We know what kind of dance to do experimentally to measure this number very accurately, but we don't know what kind of dance to do on the computer to make this number come out without putting it in secretly."
Feynman's point was simple but profound. The constants appear completely arbitrary. From the standpoint of the equations of physics, they could have had any values, yet for some reason they don't. They have these specific numbers, and no one knew why. So how do you explain them?
One possibility is to simply say, that's just how reality is. The constants are brute facts, uncaused, unexplained. Who says they need to have a reason?
But good theoretical physicists like Feynman resisted the idea that the 25 constants, an apparently arbitrary and ugly list of numbers, were simply uncaused, ad hoc patches tacked onto an otherwise elegant theory of everything. Their scientific intuition, shaped by centuries of uncovering the deep order in nature, told them a final theory should be simple, unified, and elegant, not a beautiful framework marred by unexplained numerical baggage.
So you might suggest a second possibility. Maybe there's some deeper mathematical theory that naturally generates the values of the constants.
That would be great if it were true, but to Feynman and other physicists, it seemed like an implausible dream. How can a purely qualitative theory of everything, a master law of nature, with no built-in quantities, naturally pop out 25 specific numbers like 1 over 137.035999139?
Now, at this stage, it would be premature to say, God did it. That kind of move is an argument from ignorance, known as the God of the Gaps fallacy, plugging God into the parts of science we don't yet understand. More on this later. The wise move at this point was simply to wait, to see whether physics might eventually offer a clue. And as it turns out, that's exactly what happened.
The discovery of fine-tuning was a turning point in this story. It provided the crucial clue that the values of the constants of nature aren't random or arbitrary. Beginning in the 1970s, scientists realized that while these numbers may not matter much within the equations of fundamental physics, they're absolutely essential for everything that comes after: astronomy, chemistry, biology, and the very existence of a structured universe.
Fine-tuning means that if some of these constants were even slightly bigger or smaller, the universe would be a chaotic mess. No atoms, no stars, no galaxies, no life. In other words, fine-tuning is the reason our universe contains order, structure, and complexity of any kind whatsoever.
While physicists began uncovering many examples of this, the most dramatic came in 1998 with the discovery of the cosmological constant, the number that determines the accelerated expansion of the universe. For a long time, physicists assumed that number was 0. But when astronomers finally measured it, they found it wasn't 0. It was incredibly tiny, about 10 to the negative 122nd power. That's a decimal point followed by 121 zeros and then a 1.
And this number was incredibly fine-tuned. If it had been even slightly larger, then the universe would have expanded way too quickly for any structures to form. There would be no planets, stars, or galaxies. And if it had been even a little smaller, then the universe would have collapsed back in on itself right after the Big Bang. The level of precision involved is so extreme that no one could write it off as a lucky accident. It forced many physicists to take the fine-tuning problem seriously.
Even Stephen Hawking, an atheist physicist, acknowledged the fact that our universe is fine-tuned. In his book, The Grand Design, he wrote as follows: "Most of the fundamental constants in our theories appear fine-tuned, in the sense that if they were altered by only modest amounts, the universe would be qualitatively different, and in many cases unsuitable for the development of life. The laws of nature form a system that is extremely fine-tuned, And very little in physical law can be altered without destroying the possibility of the development of life as we know it.
Hawking and others often say the universe is fine-tuned for life, and that's true. Without atoms, stars, and planets, life couldn't exist. But the more general way to put it is this. Scientific discoveries show that the constants are fine-tuned for everything remarkable in the universe. Atoms, stars, galaxies, life, and more. Yes, life is special, but fine-tuning isn't just about life. It's about the underlying order that makes anything interesting possible.
It's important to clarify this point because the claim that the constants are fine-tuned exclusively for life is an overreach that leads to serious questions against the fine-tuning argument. To avoid these problems, it's important to formulate the arguments properly. Without fine-tuning, the universe wouldn't just be lifeless. It would be a chaotic mess of particles without any structure or complexity whatsoever.
The discovery of fine-tuning didn't just raise a question about how to interpret it. It demolished the two previous possible explanations for the constants that were already unsatisfying to begin with. These were, first, maybe the constants are just brute facts, fundamental numbers built into reality with no deeper cause. Or two, perhaps there's some undiscovered mathematical law that determines their precise values.
But after fine-tuning came into focus, both of those explanations completely fell apart. This is because neither approach explains fine-tuning. If the constants were either just brute facts or blindly determined by a deeper law, then fine-tuning would be an outrageous coincidence, far too unlikely to take seriously. We now need a new explanation, one that incorporates the knowledge that these constants are precisely fine-tuned for a complex universe.
But that's not so simple. Fine-tuning poses a deep challenge because it flips the usual logic of science on its head. Here's why. In science, we normally explain how simple laws lead to complex results. For example, the laws of physics govern how atoms behave, and from that, molecules, planets, and stars emerge. In that model, cause comes first and effects follow.
But fine-tuning suggests something radically different, that the existence of complex structures, like atoms and stars, is what selects the values of the constants in the first place. In other words, the end result seems to dictate the initial setup. From a traditional scientific perspective, this sounds completely backward.
That's why fine-tuning demands a paradigm shift. It's not just a new fact to explain, it's a challenge to the entire framework of scientific explanation. It forces physicists to rethink the relationship between cause and effect at the most fundamental level of reality.
This shift is so profound that it's one of the main reasons many scientists have turned to radical new ideas, like the multiverse, as a way to make sense of it. We'll come back to that later, but for now, let's follow the logic of fine-tuning and see where it naturally leads.
The laws of physics, along with their finely tuned constants, look less like random equations and more like blueprints or instructions for building a complex, ordered, structured universe. The straightforward interpretation is that the constants of nature weren't set blindly. Instead, their specific values were chosen with a purpose to produce atoms, planets, stars, and life.
And as with anything designed for a purpose, the constants must have been selected by something that intended that outcome. This means that the cause behind these values must be intelligent, because it shows exactly the right combination from an enormous range of possibilities to achieve a specific result. After all, that's what intelligence is, the ability to pick the right option from many in order to reach an intended goal.
Putting it all together, we see that the fine-tuning of the constants, the fact that they're just right to create a complex universe filled with atoms, stars, galaxies, and life, is powerful evidence for an intelligent cause. Put simply, fine-tuning clearly indicates an intelligent fine-tuner.
For a more in-depth discussion of the fine-tuning argument, watch or listen to the first 5 episodes of Season 1 of the Physics to God podcast.
Our second argument for God doesn't come from the constants of nature, but from the laws of nature themselves. These are the qualitative laws of physics, like quantum mechanics and general relativity, that govern every interaction in the universe. They're elegant, mathematically precise, and remarkably effective. But don't worry, you don't need to understand their details to follow the logic of the argument.
Countless experiments and observations confirm that our universe is governed by quantum mechanics and general relativity. But this leads to a profound question. Why these laws and not others?
As physicist Lee Smolin writes in his book, Time Reborn, quote, "We should be able to say why the laws of nature we have discovered rather than others are the laws. Facts about the world need to be explained, and a fact most in need of explanation is why particular laws are observed to hold in our universe.
In the second half of the 20th century, physicists hoped to resolve this question by discovering a unique final theory of nature, a single logically inevitable law or set of laws that could explain everything and rule out all alternatives. If they succeeded, it would mean that our laws of physics weren't just one possibility among many, but the only possible laws a universe could conceivably have.
Despite years of effort, physicists eventually realized that the dream of a unique final theory was unrealistic. There's no logical reason our laws had to be the ones we observe. Quantum mechanics and general relativity aren't inevitable. In fact, scientists have formulated many alternative laws that are mathematically consistent, yet simply don't describe our universe.
In his 2001 book, 3 Roads to Quantum Gravity, Smolin reflects on this point as follows. Looking back, it is clear that the assumption that a unified theory would be unique was no more than that, an assumption. There is no mathematical or philosophical principle which guarantees there to be only one mathematically consistent theory of nature. In fact, we now know that there can be no such theory.
With the dream of a unique final theory gone, the question returned. Why is our universe governed by these laws and not others?
The clue to answering why these laws emerges from the recognition that our universe's laws are not arbitrary, but are special and designed. For all possible sets of laws that our universe could have had, the overwhelming majority would lead to a universe lacking atoms, molecules, planets, stars, galaxies, and life. In other words, our design laws are uniquely suited to produce order, structure, and complexity.
In the words of physicist Paul Davies, you might be tempted to suppose that any old rag bag of laws would produce a complex universe of some sort, with attendant inhabitants convinced of their own specialness. Not so. It turns out the randomly selected laws lead almost inevitably either to unrelieved chaos or boring and uneventful simplicity. In some sense, we live in the most interesting possible universe.
The realization that the laws of nature are designed leads to a compelling explanation for why our universe is governed by this particular set of laws, rather than any of the countless alternatives. Since these laws are uniquely suited to produce a complex, ordered, and life-permitting universe, the most natural conclusion is that they were chosen for that very purpose.
And since selecting one option from many to achieve a goal is the essence of intelligence, it's reasonable to infer that the design embedded in the laws of nature points to an intelligent designer, one who chose these laws from among countless possibilities to create a universe like ours.
For a more in-depth discussion of the design arguments from the laws of physics, watch or listen to Season 1, Episode 7 of the Physics to God podcast.
Now we come to our third argument for God, not from the constants of nature or from the laws of physics, but from the universe's initial conditions. This one's especially striking, and it starts with a concept from physics called entropy.
Entropy is a measure of disorder. Think of any system, a book, a room, or the entire universe. Every system has a specific arrangement, and some arrangements are more ordered than others. A normal book, for example, has order because its letters are arranged meaningfully. But if you scrambled all the letters, it would still be the same collection of pages and ink, just filled with jumbled nonsense instead of coherent ideas. That would be a high entropy state. Lots of disorder and no meaningful structure.
In physics, high entropy means greater disorder, while low entropy means greater order. According to the second law of thermodynamics, any closed system, like the universe, naturally evolves from order toward disorder. That means if a system is ordered today, it must have begun in an even more ordered state.
Here's where things get interesting. Based on probability alone, we'd expect the universe to be in a high entropy, disordered state. It's like shuffling a deck of cards. There's only one way to get perfect order, but countless ways to get randomness. Similarly, a chaotic, high entropy universe is far more likely than an ordered one. And yet, what we actually observe is the opposite. Galaxies, stars, planets, and life, all of which depend on low entropy. This remarkable level of order can only be explained if the early universe began in an even more ordered, low entropy state.
This leads to a striking conclusion. As physicist Brian Greene put it, quote, "Incredible order at the beginning is what started it all off, and we have been living through the gradual unfolding toward higher disorder ever since. End quote. That early order is what allowed our universe to evolve into what we see today. Without it, we wouldn't have stars or galaxies, just a chaotic universe full of high-entropy black holes.
Now we reach the heart of the matter. Roger Penrose, one of the most respected physicists in the world, calculated the odds of the universe starting in such a low entropy state. And the number he calculated is 1 in 10 to the power of 10 to the power of 123. This is a mind-bogglingly gigantic number.
Listen to Penrose describe it. Quote, "In order to produce a universe resembling the one in which we live, the creator would have to aim for an absurdly tiny volume of the phase space of possible universes, about 1 over 10 to the 10 to the 123rd of the entire volume. This is an extraordinary figure. One could not possibly even write the number down in full in the ordinary denary notation. It would be 1 followed by 10 to the 123rd successive zeros. Even if we were to write a 0 on each separate proton and on each separate neutron in the entire universe, and we could throw in all the other particles as well for good measure, we would fall far short of writing down the figure needed."
In simple terms, this means that the odds of our universe beginning in such a highly ordered state by random chance is essentially 0. If it had started in the far more likely high entropy state that you would expect from pure randomness, it wouldn't have produced anything interesting, just a structureless universe full of black holes.
Instead of the universe starting in a probable disordered state, it began with jaw-dropping precision. This clearly indicates that it wasn't a random fluke. Just like a coherent book implies a writer, this kind of cosmic order implies an intelligent cause that chose this particular setup from countless possibilities for the purpose of producing a complex universe filled with atoms, stars, galaxies, and life.
When you consider both how astoundingly improbable that initial state was and how essential it was for everything that followed, it's nearly impossible to believe it happened by chance. The far more reasonable conclusion is that the universe began in an exquisitely ordered state because it was intentionally ordered that way by an intelligent God.
For a more in-depth discussion of the argument from the order and the initial conditions of the universe, watch or listen to Season 1, Episode 8 and 9 of the Physics to God podcast.
Even atheist scientists acknowledge the striking features of our universe: finely tuned constants, elegantly structured laws, and an extraordinarily ordered beginning. While these discoveries naturally suggest an intelligent cause, many scientists find that conclusion deeply unsettling. Let's look at 2 of their most common objections.
Critics often dismiss design arguments by saying they just plug gaps in our scientific knowledge with "God did it." This is an argument from ignorance known as the God of the gaps fallacy. Instead of offering a real explanation, it appeals to God simply because we don't have anything better.
It's true that some scientific gaps involve small details within well-understood theories, and it's reasonable to expect those to be filled as science progresses. In fact, that's a common critique of the design argument in biology. But our arguments from physics are different. They don't arise from ignorance, but from knowledge.
The fine-tuned constants, the design laws, and the low-entropy beginnings of the universe aren't gaps we're filling with "God did it." They are well-established fundamental features of reality. It's not the mysteries that point to an intelligent cause. It's the scientific solutions to those mysteries that point to God.
As physics has advanced, we've learned these features are anything but arbitrary. The constants are precisely tuned. The laws are elegantly designed. And the early universe was remarkably ordered. All of this was necessary to produce a complex universe with atoms, stars, galaxies, and life. These aren't arguments from what we don't know. They're arguments from what we do know.
A second common objection to design arguments is this: if our complex universe had to be fine-tuned and designed by an intelligent cause, then who fine-tuned and designed God himself?
At first glance, it sounds like a devastating challenge. If complexity needs explaining, then wouldn't an intelligent cause, presumably even more complex, need an explanation too?
That would be a fair question if we were claiming that God is a complex being made up of many parts. Because if God were made of parts, then something else would need to fine-tune and design those parts correctly. But that would just lead to an infinite regress, beg the question, and leave us without a real explanation.
That's precisely why the fine-tuning and design arguments point to the God of classical theism, one simple fundamental existence. Unlike complex things made of parts, this kind of being doesn't have components that need adjusting. So the question, who fine-tuned and designed God, doesn't apply because God is categorically different from all other complex things. In other words, a simple God isn't made of parts that can be fine-tuned or designed in the first place.
Scientists' discomfort with the idea of God compels them to instead turn to an alternative explanation, the multiverse. The idea is as follows. If there are an infinite number of universes, each with different constants, laws, and initial conditions, then it's not surprising that at least one of them, by sheer chance, ended up with the precise conditions needed for life. And that universe, of course, would be ours.
But wait, if the vast majority of universes aren't fine-tuned, what are the odds that we'd find ourselves in such a rare one? Multiverse scientists respond with a clever move: observer bias. Since intelligent beings can only exist in universes with the right conditions for intelligence, any observer could only find themselves in a life-permitting universe.
At first glance, this may sound like a reasonable alternative to God, but the multiverse has deep, fundamental problems. In Season 2 of the Physics to God podcast, we analyze the theoretical support for the multiverse and explore some of the absurd consequences of positing an infinite number of unobservable universes in which every physical possibility is realized somewhere. Most importantly, we examine the devastating measure problem, a serious flaw that undermines the multiverse as a coherent explanation.
We show why the multiverse, despite its popularity among physicists, fails as a scientific explanation for fine-tuning, design, or order. For a quick overview, check out our episode, Is the Multiverse Real? For a deeper dive, explore Season 2, Analyzing and Rejecting the Multiverse.
Whether or not you delve into the details, one thing is clear. The fact that scientists are willing to invoke something as wild and speculative as an infinite number of unobservable parallel universes is telling. Scientists, who usually insist on testable, observable evidence, wouldn't turn to the multiverse unless they were deeply unwilling to accept the most straightforward explanation, an intelligent cause. That alone highlights the power of the case for God from fine-tuning, design, and order in physics.
Let's take a step back and look at the big picture. We've presented 3 arguments, each grounded in a different domain of physics. 1, the precise fine-tuning of nature's constants. 2, the elegant design of the laws themselves. And 3, the extraordinary order of the universe's initial conditions.
Each of these on its own points to an intelligent cause, but together they tell one powerful story. Our universe is fine-tuned, designed, and ordered, not just in one respect, but in every fundamental layer of its structure.
To see this more clearly, let's briefly walk through the history of the universe through the lens of modern physics.
It all began with the Big Bang. From the very start, the universe was in a state of incredibly low entropy, an extraordinarily ordered beginning.
From that unlikely starting point, the universe unfolded according to the law of general relativity, one of the beautifully designed laws of physics. And embedded within that law is a quantity called the cosmological constant, whose precisely fine-tuned value governs how fast the universe expands.
At the same time, the universe's energy formed into fundamental particles. These particles behave according to quantum mechanics, the other law of nature that displays deep design. The constants of quantum mechanics determine the mass of particles and the strength of the forces between them. These constants, too, are finely tuned.
Over time, this exquisitely balanced system gave rise to atoms, molecules, stars, galaxies, and life. None of that could have happened by accident, because without that special beginning, those specific laws, and those finely tuned constants, the universe as we know it wouldn't exist. Change any one of those 3 elements, and the whole thing falls apart.
That's why these 3 arguments don't just stand on their own. Together, they form a unified picture of a universe that unmistakably points to an intelligent cause: God.